All right, morning all, and welcome to the May 2024 Alta webinar presented by Dr. John Spargo of Penn State University. Dr. Spargo is a long-term partner of Alta and a well-respected, I guess I would say, individual in the soil testing world. He's also part of the FRST program, and I think he's going to share with us some of the initial research that they have put together, compiling the current status of U.S. soil test recommendations and methods. And with that, I'm going to hand it over to Dr. Spargo. I will remind people who are interested in CEU or CCA credits that there will be an email at the end where you can self-file, or you can send me an email and we will report them for you. With that, we'll start the webinar. Thank you, John.
Hey, thanks, Corey. Good morning or afternoon, depending on where you are in the country. It's after 2 minutes afternoon here on the East Coast. Yeah, thanks for the introduction and the invitation to present in this series. I think I've really enjoyed working with Alta over the last several years, and really appreciate Corey and others' support with pulling this webinar series together. Let's see, I've got my screen pulled up. I'm looking at the total participants. We're about 25. I probably have enough material, and I can talk nonstop for the full hour, but I'd certainly invite you guys to interject, ask questions along the way. You can save them till the end. I've got the chat pulled up and I can try and keep an eye on that, but feel free to unmute yourself and just speak up. We can keep this informal. So first, let me acknowledge my co-authors. Like many of the things we do with FIRST, it's a team effort. Sarah Lyons, who was the postdoc on the project and now is with FR, Jason Clark at South Dakota State University, Deanna Osmond, of course, NC State, Razel Parvej at LSU, Austin Pierce, who also was a postdoc on the project, who's now with Field to Market, and of course, Nathan Slayton at Arkansas. So I know most of the folks on the call or webinar this morning are familiar with FIRST or FRST, the Fertilizer Recommendation Support Tool project, but for those of you that aren't, and just as a means of introduction, as the name implies, what we're working towards is this fertilizer recommendation support tool, but the larger goals of the project is really to increase the soil testing transparency by first promoting clear and consistent interpretations of recommendations, removing political and institutional bias wherever we can, and then providing the best possible science to enhance the end user adoption of all of these recommendations. So that's the primary goal. Secondary to that, I think still just as important, creating a community of practice to help galvanize the interests and participation around soil fertility, engaging in things like this. And then finally, providing a catalyst for ongoing innovation in soil fertility evaluation, whether it's soil testing or otherwise, as well as its management. As you might expect, pretty ambitious goals takes a lot of folks, and since starting this thing really formally in 2019, we've built quite a long list of collaborators. We're currently over 100 soil scientists, agronomists, and professionals representing, I think we're over 50 universities, 4 divisions of the USDA, as well as several not-for-profit organizations, and more recently, a few private sector partners. So really excited about that. And of course, we've had support from both federal funds, NRCS, ARS, NEFA, and as well as OCP more recently. So, excuse me. This overall project is really a series of stepwise activities. I'm not going to go through the whole list of 13, but as I mentioned, one of the things we've been sort of building to since the beginning is this database to support this decision support tool that just went live about a month ago. many or most of these activities preceding that were sort of to build towards that, and then the ones that are ongoing and afterwards are to build on or sort of next stages or even branches off of what we originally started. But the very first thing that we stepped into is just trying to get a handle on where things currently are, just the current status of soil test practices and recommendations. So that's what we're going to talk about today. Just real briefly, the justification or rationale for sort of taking this on as we thought about it. I think ALTA members, especially those of you that have spent some time working in labs, recognize that over the last I'd say 50 years, certainly the last 20 to 30, we've made a lot of progress towards standardization of methods, and that largely can be credited to the efforts of the coordinating committees, each of the regions, the Western region, the North Central region, Northeast region, and the Southern regions, as well as organizations like SSSA, the Soil and Plant Analysis Council, ALTA, and others. I think we can all pat ourselves on the back. It's been pretty successful. There are still some subtle inconsistencies, and these are sources of bias. I think it's important to recognize those as we start trying to pull, are looking for opportunities where we can harmonize our recommendations. Need to recognize where those are, and we'll talk a little bit about that. Where we've made a lot less progress is toward development of consistent guidelines for both interpretation of the soil test results as well as making recommendations. Excuse me. And we know that most of the research that's been done in support of our recommendations has been conducted by land-grant universities with I won't say none, but definitely limited interstate or regional coordination. As a result, we've got these discrepancies, among states within regions, and both interpreting the soil test results as well as making the recommendations. And as our colleague Brad Jorn likes to say, it's like when you cross over the state lines, it's like magic happens. You move from one farm to another right over the state lines, take the same soil sample, send it to the same lab. And even if you get the same results, you end up with a whole different set of recommendations. And it's expected that soil test critical levels, buffering capacity, are going to vary where soil and climate vary across the regions, but those differences aren't generally associated with political boundaries. So that's one of the big pushes, and I think one of the big frustrations for end users and our clients. So that's one of the things we want to try and address and move forward. So specific objectives of the survey work are to really gain a better understanding of the current status of soil testing across the U.S. in order to inform, collaborative efforts within and among regions, as well as identify, opportunities where, we can harmonize our recommendations, where it really doesn't make sense to have two sets of recommendations for bordering states. Again, this was a team effort, lots of input from many of our colleagues. The ultimate survey that we created was actually adapted from one that Sarah Six, the Southern Coordinating Committee for Soil Testing, had put together and run out about 3 years earlier. We worked to expand the scope to collect information that was relevant to all regions, as well as just increasing the amount of information we were collecting to meet our specific goals. We put the tool together in Qualtrics, and then worked with each of the regional coordinating committees to get it administered, sent out to all of the soil fertility specialists and lab managers, lab directors within each of the states. I'll mute my phone here, apologize. Just a general overview, the types of information we were collecting. We looked for information like how many faculty full-time equivalents were currently working on correlation calibration, sources of funding if there were any state funds to support that work, general status of recommendations, information on both critical soil test levels as well as cutoff levels if those two aren't the same, i.e. the critical level, the soil test level above which we don't expect to see a response to fertilizer addition, whereas the cutoff level is the soil test concentration where we stop recommending phosphorus or potassium. Philosophy, terminology, specifics about methods, as well as some other information, ongoing work with soil health, proficiency testing, and that kind of thing. So as you can imagine, lots of questions we can ask among all of those. We ended up with a pretty big survey, 100 questions, 9 different total categories. We pulled the whole thing together and first sent it out in February of 2020. After following up and giving folks lots of opportunities to complete it, we closed it out in June of 2020. In the end, we ended up with 60 responses representing 48 states. We were pretty happy with that. So we basically have a response for every state plus Puerto Rico, except for Nevada and Alaska, and we just couldn't identify anyone there to provide the information we were looking for. So over the next year plus, remember this is COVID time, we compiled all of the responses, went through, reviewed them for consistency, and then followed up with each of the participants now that everything had been summarized and pulled into these tables, and asked them to take another look and review it, make sure it was accurate, identified and corrected any discrepancies, filled in any missing data that we had, and then finished all of that up by May of 2022. We have since published the whole data set, which is published in Ag Data Commons, the National Ag Library. I provided a URL, anybody that's interested in taking a look at that. We also published a subset of this information, what I'm mostly going to focus on today, in SSA J, and this is also an open access, so everybody can take a look at that. I also provided a URL on the chat for that if anybody's interested in looking at that. All right, so let's turn to the results. So one of the things that we recognized is that whether a state does or does not have a public soil test lab may have implications for how the methods as well as the recommendations are viewed by folks working in that area. So unlike back in the 50s, today we're only looking at about 30 states with a public service lab offering soil fertility testing as well as recommendations. A couple of things to point out. This was May of 2020. Since then, I know Michigan's lab has closed down. I feel like there's one other in the North Central region. I'm blanking on it right now. UNH and Vermont continued to receive samples. They actually subbed the analytical work out. So they're still collecting the samples and managing the data, but the actual analytical testing is done elsewhere. Kind of a unique model for those 2 New England states. Of the 4 regions, Western, North Central, Northeastern, and Southern, the Southern region is the only one where every state currently has a public service lab. Start off by looking at some information about sampling. So the map illustrates recommended sampling frequency ranging from every year through no specific recommendations. About 20% of states, so a fifth recommend sampling every year. Another 16% every other year. About a third either every 3 or 4 years, which is where we fall out in Pennsylvania. And the reason why that works out is that's about the frequency that we would recommend lime. So the liming cycle once every 3 or 4 years. It's interesting the every year. Kind of surprised me that many states recommending every year. I guess good for those of you that make money testing soils. And then a smaller fraction, 16%, have more of a varying frequency based on crop or cropping system or a specific soil type, which makes sense. Maybe on a less well buffered soil, maybe you recommend sampling more frequently. On a well buffered soil, maybe less frequently. With sampling depth, we had a range of recommendations from 0 to 4 inches all the way to 1 foot. Of course, the most common sampling depth, excuse me, is 0 to 6 inches. The next one would be, in the 0 to 20 centimeter, 0 to 8 inch segment. About 1/3 of states have recommendations, tillage specific recommendations for sampling, with either a shallower sampling depth, say, for conventional till, their routine depth would be 0 to 6 or 0 to 8 inches, but for no till, they go to a 0 to 4 inch sample, or using a stratified sampling depth. And that's actually, along the lines of what a lot of us have done in the Northeast region, especially early on when we weren't managing soil acidity very well and no-till, and we'd end up with these an acid roof, and you'd see your triazine herbicides stop working effectively because you'd managed to get a pH at the soil surface of 5.5 or 5.2, even though in the furrow slice it was still above 6. Another interesting one. About 1/3 of states have provide recommendations or guidelines for precision sampling in support of variable rate fertilizer applications, which if you look at the industry survey, lags behind a good bit by the actual amount of fertilizer that goes out based on variable rate. The other interesting piece that I think kind of goes along with this is there's also not as much research in support of this as I think, at least is with what the recommendations suggest. So this one I think was an interesting one, and I think I think provides a really good example of why it's really important that the efforts that FIRST is putting out there to improve the precision of our interpretations and recommendations, and the implications for that, especially in variable rate fertilizer applications. All right, shifting gears to now methods. Two maps here, the top one summarizing the soil test phosphorus methods, the bottom one soil test potassium methods, and the key, sorry about the small font. First, looking at the phosphorus methods, we currently have 8 methods recommended for P. Not surprising, Olson is the dominant one in the west, Bray and the north central, slowly being replaced by Mehlich 3, and then Mehlich 3 in the south and really mid-Atlantic region, with the New England states being unique in that they're still recommending the Morgan or modified Morgan for phosphorus. Another one to point out here is that Iowa, Michigan, Puerto Rico, South Dakota, and Washington all recommend multiple tests based on either the specific region within the state, soil pH, or other factors. Oops. Similarly, for potassium, 8 different methods recommended across the U.S., ammonium acetate and Mehlich 3 being the most common. Again, Iowa and Illinois have recommendations for both. An interesting thing, and I thought I knew most of the interesting things about soil testing before doing this survey. I didn't realize that the Olson could be used as to measure potassium. I guess I never even thought about it. Likewise, that Bray could also be a potassium method. Additional methods on the soil test portion, we asked about what size scoop do you recommend? And we know that volumetric measurements have historically been the most widely used or common way to collect that test portion, because it's fast, and in order for soil testing to be practical, it needs to be quick. And when performed by an experienced analyst, we can get pretty good precision out of it. Most of the states that we surveyed reported that they are using a fixed volume with a standard scoop, and then applying an assumed density to convert those results to a mass concentration basis. And that's been around for a long time. The North Central region has the standard scoop that assumes that our dried sieve soil is 1.18 grams per cubic centimeter. So for example, a 2-gram scoop would be 1.7 cc's. And then we just multiply whatever our concentration is on the extract by 10 if we're using a 1 to 10 extraction ratio, and there you have it, milligrams per estimated kilogram. The challenge is that we've got a lot of diversity out there. So to illustrate that, what we did is I'm just summarizing the test portion, the sample size here in cc's, the actual volume of extract, and then the assumed density used for reporting, or was it actually done on a weight or volume basis for all of the states that have Mehlich 3 recommendations. And you can see, a diversity and both the scoop size and volume, and across the board we're maintaining a 1 to 10 extraction ratio. The trick is that 1 to 10 extraction ratio is either on an assumed weight, an actual weight, or just a straight volume. And when we go through and plug in the either assumed weights, actual weight, or just on a volume basis, you do end up with different numbers. And this is one that I feel like there's been lots of discussion about. When you go back to Mehlich's work, before Mehlich 3, but definitely including the Mehlich 3 method, he talked a lot about it. I know that there have been a number of papers that have looked at these differences, and it's still really frustrating to me that we've still got this source of bias. Still, I think the important thing, and why it's valuable to collect this type of information, is because knowing it's there can help us manage it, and I think that's the critical piece. All right, shifting gears and now looking at recommendations. One of the things we asked about is, are your official recommendations based on a build and maintain or a sufficiency approach, some hybrid or other philosophy? And because there's, we didn't want to leave any room for interpretation there, we went ahead and defined, what we meant by build and maintain and sufficiency. And this isn't the complete definition that we provided, but I think captures the essence of it, where build and maintain are recommendations made with the goal of building soil test nutrient levels, typically over several years, up into that optimum range, and then maintaining those by applying nutrients at a rate that approximates crop removal, up into a point where we do, go to zero. And this is an illustration of these are Penn State's recommendations for Mehlich 3 phosphorus for corn, I think with a yield goal, corn for grain, I think with a yield goal of 190 or 200 bushels to the acre. And you can see, when we're below optimum with our critical soil test level of 30 part per million, we're applying enough nutrients to both meet crop removal as well as enough to build soil test levels over time, not all at once, but over multiple years. We get into what we define as the optimum range, so above our critical level up to a cutoff level, and we're applying, a fraction of crop removal up to the cutoff value. And then once we get above that, what we're calling the upper range of our optimum range, we're going into drawdown. So we're removing nutrients. We're not applying any, so the thought is we're mining it back down into the maintenance range. is counter to a sufficiency approach, and I don't have a figure to illustrate that here, so bear with me. It's more of a conservative philosophy where nutrient recommendations are intended to just meet crop need, not build soil fertility. So, once we get up above that critical soil test level, our recommendations go to 0. And, you can think of it as being more or less a straight line from the maximum rate, all the way down at the lowest soil test level up to a 0 down at the critical level. So at least theoretically, a sufficiency approach provides us with a higher return on investment because we're only applying fertilizer when we expect a high probability of seeing a response. However, it's also riskier because there's always uncertainty both in the interpretations and recommendations as well as the actual laboratory measurements. So looking at the results, almost 40% of states reported that their recommendations are based on a sufficiency approach, with only about 20% identifying as build and maintain, with another 20% suggesting that they're using more of a hybrid approach, something in between sufficiency and build and maintain. And when we start drilling down and looking at specifically how those recommendations come together, you see that there really is a lot more overlap among these. It's just how they define where they fall in those 3 bends. And then finally, and this is I think this was really interesting, and I think if you've got the time to drill into this a little bit further, I would encourage it. About 20% provide recommendations following these multiple approaches. And the one that I think I like the most is Kansas's approach, where they actually provide both. So a build and maintain set of recommendations, as well as a sufficiency set of recommendations. The thought there being that that's really, the decision should really be up to the person who's managing the piece of ground. Think about it, if you've got fertilizer prices are good, fertilizer prices are low, crop prices are good, you're on a piece of ground that you own or have long-term tenure on, then maybe following a build and maintain approach makes sense. But the opposite scenario, bad low crop prices, high fertilizer prices on rented ground, why spend the extra money to build soil fertility levels for somebody else to pick up? There it would make more sense to follow a sufficiency approach. So rather than making that decision and just sending out the recommendations to be followed blindly, it does make more sense to provide folks the information they need to make informed decisions. Shifting gears again, looking at we wanted to know the current status or the provenance of states' phosphorus and potassium correlations. So we asked, when were the current soil test correlations established for phosphorus and potassium, and specifically for corn. We collected it for multiple crops. Here I'm just presenting the results for corn. I think the bar graph just sort of broken into 3 bends. To the right, some sense for optimism. Over 20% of states have either redone or at least validated their soil test correlations since 2002. So within the last 20 years when we sent the survey out. About a third were older than that, prior to 2022. The thing that really concerns me though is that 40% of respondents didn't know. They didn't have sufficient records that they could go back and determine when those were established, and that's concerning. We also followed up, and I don't have this summarized in a figure. We asked them the same question about their calibration. So when was the last time that the phosphorus or potassium rate recommendations were revised or validated? This bend went up a little bit. It was more like about a third. where they had more recently updated those. I'm sorry, half of the states surveyed had updated those within the last 20 years, which is, you know, a good thing. Another third, and this been, you know, within the last 20 years, and the unknown category fell to 20%. One of the other questions we asked about was, you know, how many full-time faculty are there currently working on soil fertility research, and you know, asking folks to express that as full-time faculty equivalents. So we'll go all the way here to the right-hand side of the curve. On average, that value today sits at about 1.3 FTEs per state. Varies a little bit by region. We pulled in this data from Regis Voss from a paper published in 1998 to look at how that has changed over time. So from 1951 through 94, that's all from Voss's work. This is from the current survey. Again, plotting it by region, looking at just the average, you know, we're looking at about 22% decline every decade to the present. You know, in the Western region, you know, starting out at 5 back in 1951, they've had the most precipitous drop. The Northeastern region has never really been in great shape, and is you know, also not in great shape today. The only one where there was, I think, an interesting trend here is in the Southern region. You know, pretty low numbers going all the way back, and falling even lower than what we have in the Northeast region. More recently, you know, an average of 1.3, 1.5 is actually, you know, pretty good for the Southern region, you know, based on historic standards. So. The other question we asked, and I didn't provide a detailed summary of this, is about dedicated funding, state funding from things like, you know, taxes or fertilizer tonnage fees in support of soil fertility research. It's currently available in about 15 states, which, you know, records suggest is a decline. The interesting thing is based on what I knew, I really expected that to be focused in the North Central and Southern regions. It's actually pretty evenly distributed. 5 states in the Western region, 5 states in the North Central region, 5 states in the Southern region. The only region that doesn't have any states where we've got tonnage fees or taxation to support, you know, state funds specifically to support fertility research is the Northeast. All right, and the final category of questions that I've got summarized is, you know, we asked about, you know, on any examples of historic or ongoing collaborations, and our colleagues provided a number of, you know, I think successful examples. One that many of the Alta members I think will be familiar with is the tri-state recommendations. It's a collaborative effort between Ohio, Michigan, and Purdue, and gosh, I think they started that back in the 90s. It was just recently updated within the last 4 years. Steve Coleman led that effort, and that's been republished. Couple of examples, additional examples, one in the Northeast back in the late 90s, an effort led by Joseph Heckman at Rutgers. Go back and take a look at soil test phosphorus calibration for corn, both grain and silage in the Northeast New England states. And they had like 52 site years of trials. You know, I pointed out in the Northeast, we've got Malick 3, Morgan, modified Morgan, Malick 1. We've got a pretty diverse set of methods, and one of the goals was, in addition to validating our recommendations, to see if we could pull in and come up with, you know, at least, you know, maybe reduce the number of extractants that we were using across the region. In the end, we collected some reasonably good new calibration data. However, none of the states switched extractants. We're all still either using or recommending the same extractants. And then finally, an effort in the Mid-Atlantic region led by Steve Donahue to develop a standardized set of fertilizer recommendations, or at least guidelines, across several Mid-Atlantic states. And they're, it's not that they had the same recommendations coming out of that, but they definitely reduced the amount of variability and identified at least justification for why they might be different. Colleagues provided a number of other examples where folks worked to try and come up with or harmonize soil test interpretations or recommendations, even the concepts. However, not a lot of action taken. And finally, circling back to conclusions. So I think the results clearly demonstrate the need for updating soil test phosphorus and potassium recommendations. Meet crop needs, promote the economics of nutrient use, prevent loss to the environment, and clearly communicate the philosophical components of our recommendations. Certainly a need for more regional collaboration and consistent soil sampling, analytical methods, soil test interpretations. These are all increasingly important. And one of the big things I feel like one of the critical pieces of all of this work is we need to make improvements on how we document the basis for our recommendations and making that justification available to our clients. And finally, the loss of faculty working in soil testing and fertility is certainly a big concern. And it's due to the parallel loss of the institutional knowledge, as well as the data that often gets lost when faculty retire. Recognizing that trend's unlikely to be reversed, it really highlights the importance of working collaboratively across geographic and political boundaries. And again, that's one of the big goals of FIRST. Before opening up to questions, a number of acknowledgements. Huge thanks to Diane for her efforts creating the survey. All of our colleagues for working with us on beta testing and providing really critical feedback in the early days of pulling this survey together. Of course, all of the survey participants, 100 questions. It was a pretty arduous task to complete that and then review all of the tables afterwards. And of course, thanks to the NRCS and ARS for partially supporting this work. With that, we got plenty of time for comments and questions.
So, John, I'll just say I appreciate your presentation. Excellent. I have a few questions I wrote down, but I would love to open it up for the other audience members to either share their questions in the chat or just come off mute. Otherwise, I have a list I'm happy to kick off with.
Hey, this is Sarah. I have a question.
Oh, hi, Sarah.
Hey, great presentation, John. And of course, this work continues to be so valuable. I'm excited to see it's continuing to be the driving force of FIRST. I have a question about, you showed that there's some tables and figures there that are already antiquated and some things have changed even in the last few years.
Oh, yeah.
Can you, and being from a place where I understand the gravity of the amount of work that it took putting this together, could you see it becoming like at every 10 years the survey is put out, or could you see kind of pushing the same survey out regularly to try to get those up to date?
Yeah, so Sarah, really great question. That was one of the things I was thinking about as I was reviewing the slides this morning. So we sent this out. It was, what was it? I just said February 2020. So almost 30 years after Voss did theirs. And remember, when we pulled this together, one of the things we were looking at was we were looking at Voss's summary tables, and from that trying to figure out what they asked to get that answer. And one of the things that I really appreciated about pulling this together and getting it into Ag Data Commons is that not only did we publish all of the tables, we published the survey, so that 10 years or 20 years down the line, if somebody did want to go back and repeat this, they don't have to, well, God, I hope that they don't send out all 100 questions, but, very specific ones. And the other cool thing is, one of the big lags for us in pushing this out is we weren't quite sure who to reach out to. Some of the folks that took this, I know, retired just within the last 3-4 years. But we've got contacts for the folks that are still there. So yeah, I think I do think that circling back and probably rerunning this, I'd say once every 10 years or so, just to update it makes sense. We've got the opportunity to do that. Good question.
So I'll just I'll build off that comment. One of the things that I struggle with, or a challenge that comes to mind whenever I hear you or Nathan Slayton talk on this topic, is that there is at least in some regions, there's a breakdown between what the written recommendation is, what maybe even the university lab does, or the land grant, the state lab does, and then what is being done in the industry and what is being done by farmers.
Right.
And so I have two questions off that. What would your thoughts be about trying to maybe rework this survey or parts of it and direct it to actual labs, industry labs? And what can you comment a little bit on that kind of breakdown, or maybe breakdown's the wrong word. I don't, that disconnect that happens. Any thoughts there?
Yeah, and that's one of the things we talked about actually when we were pulling this together. Trying to just wrap our hands around, our arms around the land grant university recommendations, I think was pretty tough. I think part of the motivation for really focusing on that, though, that's a realm that we can have direct influence on, and with the thought being that in many cases, especially where they're when you're with regard to nutrient management laws, those are the official recommendations. With regard to understanding both the, let's say, university recommendations versus private lab or consultant recommendations, those comparisons have been made before, and it is interesting. I think one of the things that often comes out of it is they end up being very Corey, they end up being very antagonistic, and I don't know that necessarily serves the purpose, which is to move things forward. So I think it would be interesting to go through and even just for a single crop, maybe a few, and look at it with a common extract, look and see what everybody's recommending. If there was a way to do it without calling people out, I think it'd be a fun academic exercise. I think for first, more importantly, I think is trying to collect and create this space where we can provide the framework for soil test correlation data, so we're all looking at the same thing. We've got a tool that we can use to interrogate the data and figure out at least where a tipping point is, so that we're all looking at the same thing. And then I think the next big lift for first is the calibration piece, where we're actually determining what the probability is to response, and for a given nutrient addition, and basically from that point, we can move forward, and it doesn't necessarily mean that that's what everybody should be recommending, but it provides sort of the we'll all have the same yardstick to compare it against. So I'm not sure if I answered your question. I think the short of it is, I think at this point, I think our efforts are better spent trying to come up with a means of collaborating to get us all to the final end goal, rather than in the old days where we were looking at I can think of a couple papers 20, 25 years ago looking at university versus private lab recommendations, and they were being really critical of the private labs for over recommending nutrients, and you look at from one university to another, the same sort of criticism could be made just among universities. I don't think it necessarily serves anyone to just cast stones like that.
No, that makes sense. I guess that I like the word collaboration that you said, and I think that's an important part of this question. One of the a couple of the things that kind of came to mind specifically during your presentation is the fact that so many of the recommendations we now have are either unknown or prior to 2002. So likely the unknowns, I'm going to assume, are probably even farther back than 2002. And so I think it's a situation where maybe in the past the industry has created problems, but since then there's been a lot of change since 2002 in how you do soil testing, like on the ground on the lab bench, has changed dramatically. And so I just wonder about that. Sometimes I wonder about the relevance of some of these older recommendation models that haven't been calibrated, haven't been checked. And one perfect example that you mentioned, that I think on your map, most of the Midwest still had, or the North Central region still had Bray P1 as their recommendation. But I can almost guarantee the vast majority of the test results going out are probably some kind of Malic 3 phosphorus that's being corrected.
For sure.
And so these things are happening, and it's, I don't know, that's just one of these things that concerns me, that I think about, that I'm excited that FIRST is engaging in. I don't want to get on a soapbox. Hopefully, maybe, I think I saw someone else went off mute. Maybe they have another question.
From the perspective of a commercial laboratory, and I've worked in commercial laboratory for about 37 years, the questions come about in comparing numbers from lab to lab, so forth. First of all, I'd like to congratulate you on completing this paper. This is going to be excellent. It kind of makes me want to put together kind of a brochure of helping people understand what these numbers mean, because that is what our clientele constantly asks. What's the difference between this number and this number? And I try to explain to them that not all phosphorus numbers are created equal, and that not all application is equal. So it depends upon things. So thanks for providing this. It's a great place to start the conversation and to demystify the results, so to speak. But also, there are so many special applications that need to be addressed, and that's where our agronomists and everybody need to come in, and so forth. But you're absolutely right on the Bray P1. In Wisconsin, where we're centrally located here, it is mandated by the state government that Bray P1 is the phosphorus recommendation.
Yeah.
And so, it would be great if we could all just use a universal extractant, but that's not the solution either, so to speak. So more than a question is, how can we kind of streamline this message into kind of a brochure type of situation to get it out to the inline farmer? That's my question to you.
Yeah, I'm not sure I'd be the right person to streamline anything. I think I want to put it in context and provide you all the if thens and it depends. do think that you're right. I think for our clientele, a lot of this really needs to be boiled down. And we've certainly attempted to do as much of that as we can with FIRST. I do think it's important that we're careful. When we start aggregating information and is trying to boil it down into a 30-second video or a bulleted fact sheet that we don't lose.
Kind of a sound bite. We don't want to lose the essence.
Yeah. But yeah, I mean, I think it's important, and I think to your point, with both what Corey brought up and what you were inferring to, with the Bray versus Malik. I mean, that's one of the things that we ought to be able to look at with, if not with the data that we currently have in FIRST, I think with the data that we hope to have within the FIRST tool, is that being able to compare Bray and Malik 3 within a given region and really make the argument of is one really superior to the other, A, and B, what is the critical soil test level if we're just looking at Bray or just looking at Malik 3. Circling back to what Corey mentioned about the age of our correlation data, I think that's justifiable to be to question recommendations or even just interpretations based on data that's 20+ years old, older cropping systems, older hybrids, different climate. What I'll say is that what's interesting, at least the querying that I've done with the FIRST, looking at old versus new data and where things fall out, I don't think that things have really shifted as much as you think. Now, they might have, but there's just so much uncertainty in soil testing that within the confidence interval, the uncertainty, you can't see a big shift over time. That said, we need more data, and I am a huge advocate of getting the trials out and doing more soil test correlation calibration work today with modern hybrids, climates, cropping systems, et cetera.
I think that's a good response, and I really keyed in on one of your comments, which was that, or your thoughts there, which was that there's a lot of variation in soil testing in general already.
Yeah.
And that's possibly the bigger issue, even before we start talking about what's the right method and stuff, is how do we trim down some of that variation that's happening. And a lot of that's related to the field, a lot of that's related to what's going on in the lab. I know there was a really good soil carbon paper that was just published, I think, this month, that talked about how variation in practice in the lab is dramatically impacting soil carbon testing results. And I would argue that probably that's very much true in the fertility space as well. So with that, are there any more questions for our presenter? I know we want to be respectful of people's time, and it's 5 till the top of the hour.
Thank you very much. This is excellent.
Thanks, Chuck.
John, I was gonna ask you, to settle the debate. What is better? Should we be using a build, maintain, or a sufficiency method?
Oh man, that's again, yeah, it depends. I
need your soundbite answer on this question.
Yeah, on owned ground when prices are favorable, I really like a build and maintain. If you've got a lot of confidence in the data, and you're on rented ground and prices are not, favorable, then sufficiency just makes better economic sense, but it's risky.
Fair enough. And as
Sorry.
someone who is kind of in the South, I have a question I always wonder about, and why is there so much, why are the public soil testing labs more prevalent or stronger in the South versus lots of the other parts of the country? Do you have any thoughts on that?
I've asked that question a bunch. And what's interesting is that a lot of the labs themselves are state supported. So, you know, testing is not, if not free, it's heavily subsidized for growers. I don't know. I don't know. I don't know why it is, but it's interesting for sure.
I always kind of wonder if the South is kind of the sweet spot where agriculture is a prominent enough a part of the economy to for the states to value state funding to support the labs, but small enough that they can do it. Whereas in Midwest states where you have millions and millions of acres, the cost associated with running a state lab would be it would be a whole different size of operation in a lot of ways.
Yeah.
If you were going to try to set up a lab that could service all the soil test needs of the whole state.
Yeah. I like it. It's the sweet spot. Yep.
To help John out, it depends.
Yeah. That's right. Yeah.
Well,
Gosh.
unless someone wants to jump in here with any more questions, I'd say we can thank our presenter, and again, the recording will be available and sent out hopefully later this week. If anyone needs CCA credits, there will be a QR code you can hit in the email coming out, or you can email info@alta.ag and we'll help you get that set up.
Great. Hey, Corey, thanks so much.
Yeah, thank you very much, John.